Okay, so today we are gonna do um, Clifford normal form with the calculus. So we'll have a diagram in graph-like form, and we'll try to put it in Clifford normal form, thanks to local complementation and pivoting that will explain. So here it is. Maybe if I had a whiteboard, I do it here without my face. I prefer doing it without my face. It's better, I think, for you and for me. So that's the graph we have. So that's p over 2 everywhere, here there's p over 2, here there's p over 2. You can skip until I finish the drawing, because there is nothing to understand, that just the exercise at this point. Um, Pi over 2. To remember you, H ages is just an H with another mar. It will not be helpful here, but I mean, yeah, where this is equal to Adamar, this being this, Adamar being this. It's not useful to. I'm just, yeah, I don't know. Maybe it will be helpful for some people. So, okay, that's it. But you do not have to use it to know this. Um, okay, and so here you also have p over 2, and here 2, and here too. So I show you a way for doing it, but I think you also can do 5 local complementation and achieve the results. Here we use pivoting and local complementation. So for example, we can take these two and do a pivoting about them, these two nodes. So you see these two nodes, they have in common, this node has in common this node and this node. So we just take it like this, and this node has in common this node and this node. And so um, we just need to apply. So what I advise you is to begin as I did by when you draw something a little hard like this, to begin uh, by the external node. So you see this one will not, this one, the phase will be impacted, but the node will still stay and this node will disappear. So you just can write it like this and draw it big. This way you will have enough place to do what you want to do. So the rule is when you have those two nodes, the common nodes take um, like this node and this node, because they are common to this one, they'll take the phase of the other one, so the phase of this one. So you just take p over 2. Yeah, you just take p over 2. So you have p over 2 and p over 2, it makes p. And same here. So this one take p over 2, and he already has a phase of p over 2, and p over 2 plus p over 2 is equal to p. So here it is. Here nothing changed, you still have a phase of p over 2. Maybe better you draw your circle and after you do the phases. Because I have the habitude, I'm not doing it, but maybe it can help. So we do not care to reproduce exactly the thing, so it's not exactly the same line, but if you have the same phases, etc., same gates, it does not change a lot. It changed nothing. Because this equals this. Like you can do what you want, so you do not care. Still, you don't have gates. It's a snake rule. Okay. Because it's like a snake and you can kill it and it become like this. Okay. So now we'll begin to play my boys. So here we have this. Um, so here, what's the phase? The phase is so you have those two nodes in red, and this phase is okay. It does not change nothing because it's not impacted. Because we did not put in blue, in green, or in red. It's not impacted. So we just have p over 2. No problem. Okay, here the same. We have p over 2. Do the simple stuff, and after we'll begin to play. Okay, here it is. Now we have here and here and here some phases, so we just can yeah, you need to connect. Maybe just put so those two nodes disappear. Here that stays. You can see it. You should conserve it. Okay, you do this. After, so you need to draw a link between all nodes that are not in the same group. So here the two blues should be connected to the two green. So connect each blue to each green. It will be great. So first blue to first green. So let's say this one and the other one here. Okay. After, you can do, well, you see here we need to put the two blue and green that is here. So because we have problem of phases, we have p over 2 because the other node is here we just have p over 2 and p over 2, so we don't have problem, but it will be we add p over 2, so it become pi, and same for the other one. Okay, so you add it like this, and yes, so you need to connect this one and this one, so it's just this one and this one. You need to connect this one and this one, so it's just this one and this one. You need to connect this one and this one, so it's just this one and this one. And you need to we made all the connection, if I'm not wrong. Yeah, seems pretty okay for me. We just made everything. So yeah, that's it. Okay. So that's the first step. Let's do the second step now. So we can do one more time pivoting about those two nodes. So one more time we take the common neighbors. So you see that the neighbors of him are him and him, and the common neighbors of him are him and him. And so we can go back to work again. This far. Okay, so here we are. So as I told you before, I'll just do the simple stuff first. So you know the okay, and so the phase here will change. So we have pi and pi, so we just add pi to pi over 2, which is 3 pi over 2, which is minus pi over 2, because it's 2 pi. The, it's 2 pi minus p over 2, and 2 pi is 0, so it's 0 minus p over 2, so it's minus p over 2. But you can write 3p over 2, it's equal. That's it. Um, so exactly the same there. Uh, well, you just need to write the circle here. Here isn't the same, but it's pi minus pi and pi minus pi. Yeah, as I told you, you know. Quoi donc? Oui. No. And so that's it. Okay, so here we are. We just need to put you know, same thing as before. Keep this. And so we connect this node and this node, for example. That turns the other one. And this. Which is literally this and this. Because yeah, you understand. Here, the net's different too. So you can do it like this. That grid will have a hop rule. So here you see we already have this. I did not put it before. I forget, but you see, oh, I see it. So I put it, and because you're not not the same group, we had another H being reference to theater role. So you see, we have to upload. So we'll do some simplification. Will be great. Um, yes. Well, maybe I just did not see something else, which is the fact that we have a third group here, which is common to the two nodes. It is common to here and common to here. So we need to connect this node to to this one, to this one, to this one, to this one. And because it's like this, it's like AP plus BP, like it's two first nodes, two principal nodes, minus plus 1p. So we have 3p, which is 1p, plus p over 2, which is 1p plus p over 2 is like 3p over 2, because 1p is like 2p over 2, plus p over 2 is 3p over 2, which is minus p over 2. And so we connect him to this node, like the nodes that are here, to uh, so we connected him to the two nodes before, and yes, I think that's okay. Yeah, he is connected here, 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 here. So that seems okay. So now we can apply the hop flow twice here and here, which is like the fact that this is equal to this. If you have two balls connected, two links you can remove. Okay. So we have this minus p over 2 minus p over 2. Okay. We hop flow here, so it does not exist anymore. And there is one here too. So we still conserve this. Conserve this. Conserve this. We conserve this. But this disappear. Normally we have what we need to have. Okay, great. So the next steps will be to do a local complementation here, because here we see we have this node, and it is connected to this one, this one. So if we do a local complementation of a phase, we add the opposite phase to the common neighbors. So here we have minus p over 2, so we add a phase of p over 2 to our common neighbors, so it becomes 0 and 0, and here it become pi, but after we'll draw some connection between the nodes, and so at the real point we will have this one connected to this one, uh, because it connected them, this one to this one, create a second link there, a link there, and a link there, and then we will destroy all of the nodes and being separated thanks to the hop law we applied before with the two edges, and finally achieve the Clifford form. Okay, have 20% left. Keep it in mind. Okay, so let's go. Last step. Perfect, no? So as I said, because it's we'll add the phase p over 2 plus p over 2, because it's the opposite phase we take gives p. Here it becomes p over 2. Here it's become p over 2. Well, as I told you, it's better to, take all the place you can. So let's take all the place we can. This way it's better. Okay. So it's become pi over 2, it becomes 0 at the end, because minus pi over 2 plus pi over 2 0, same here, and here same than here, so pi over 2. Okay. So this node disappears, and Maybe I can begin to draw this. This. You still have this because up disappears, but you should connect each node. Here you have this, so you need to create this. Here you have this, so you need to create this. Maybe we can put this first. Let's see them. Here. So that's it. Um, okay. Well, I first thought I will do humor video on YouTube, and I'm here doing mathematics, but that's okay. That's life. Okay, so we're here. Here you have also this on here, so you just draw this one. And here you have this one and this one. So you draw this one. Yes. I was answering a friend on Discord, and so here you also. Well, that's it. Normally you achieve, so here it disappears, it disappears, it disappears, it disappears. And you're free. You're free. You achieve your Clifford film. There is no. You made what you wanted to make. So here was a great exercise. There is not corrections online, like online corrections of exercises like this. So I think if you want me to continue, I do some if you want. So here it is. We transform a Clifford normal form graph into a Clifford normal form, thanks to local complementation and pivoting. Okay, bye.